Okay, so now we're going to go over bundle pricing as another price discrimination strategy. Under bundle pricing, what the firm does is rather than sell two items separately, let's say that they own the market for candy bars and own the market for apples, so they're the monopoly seller in both. Rather than selling those two items separately, what they're going to do is they're going to bundle them together. And the only way to buy either is actually to buy the bundle that has one candy bar and one apple. Right? This type of pricing strategy can work particularly well for the firm when consumers' valuations are negatively correlated. That is, when someone tends to have a high value for one of the items, it means that they'll probably have a low value for the other item. So if someone has a high value for a candy bar, they probably have a low value for an apple, and vice versa. Okay? And I can illustrate this using this example here. So we're going to assume that there's two individuals in this market, Tom B. and Julian E. Tom B. has a relatively low valuation for a candy bar, but a relatively high valuation for an apple. He values a candy bar at $2 and an apple at $4. Julian is the opposite. He places a higher value on a candy bar. He places a value of $5 for a candy bar and $3 on an apple. Okay, and we're going to assume that the valuation they place on the bundle is just the sum of their valuations for each individual product. So for Tom B, his valuation for the bundle is 2 plus 4 is 6. Okay. And for Julian E, his valuation for the bundle is 5 plus 3 is 8. So that is the most that Tom B will be willing to pay for the bundle would be $6. So he'll buy it at any price $6 or less, assuming that's the only way to buy it. And for Julian E, he values the bundle $8, so he'd be willing to buy it for any price that's $8 or less. Okay, and we're also going to assume that marginal costs are 0 in this example. It simplifies it. It does also help us a little bit because bundle pricing tends to work particularly well when marginal costs are low. So you can keep that in mind. Okay, so let's look at this. So there's two possible strategies if you're just selling a candy bar on its own. You could try and sell it to both of them, or you could try and sell it to just one of them, sell it to Julian at a higher price. If you're trying to sell it to both of them, they'll both buy at any price that's $2 or less. Okay, and so you might as well charge the highest price possible, $2, if you're selling to both of them. In that case, both of them buy it, yielding a revenue of 4. And under the assumption that costs are 0, you would have that profits are 4. So I can write this for a candy bar alone. So candy bar. The price is, well, if you set the price of $2, profits would be $4. Okay, but there's another strategy here. You could instead just try and sell it to Julian, and he'd be willing to pay a price as high as $5. So if you were to charge him a price of $5, you would actually yield revenue and hence profits of $5 in this example. So that's actually better than the $4 that's depicted here. So I'll replace that. Okay, so $5 is the price, and the profits is also $5 because there are no costs and they're only selling one unit. Okay, now let's look at the apple. There are two possible strategies here. You could sell to both of them at a price of $3. That's the highest price you could charge and still sell to both of them. And you'd sell 2 units at $3, yielding $6 in revenue. Since costs are 0, it'd be $6 in profits. If instead you tried to just sell to the person with higher valuation, Tom in this example, you could charge a price as high as $4, yielding $4 in revenue, $4 in profits. Clearly, trying to sell to both of them at a price of $3 and selling 2 of them yields higher profits of $6. Okay, now let's think about the bundle. Suppose that you didn't sell these products separately, but only sold the bundle to consumers. Okay, you could either sell the bundle to both of them at a price of $6, and that would earn $12 in profits. If you tried to just sell to Julian, the profits will be a little lower, $8. So clearly we should set a price equal to $6, and that yields $12 in profits from the bundle. Okay, so let's look at this. The total profits from selling the two goods separately was 5 plus 6, or $11. Under the bundle pricing strategy, the profits are $12. Okay, so clearly the bundle pricing strategy was better in this example. Okay, so why is it helpful if valuations are negatively correlated? I can illustrate that using a graph. So on this graph, on the vertical axis, we're going to have the valuation for, I'll just say, candy bars. And on the horizontal axis, we'll have the valuation for an apple. Okay? And I'm going to draw it, so each point, which represents a person's valuations for the two products, is going to be at a point where if you sum the height, which is their valuation for a candy bar, and the horizontal distance along this graph, which is their valuation for an apple, that those two valuations would sum to 10. Okay? So in this example, if you were to choose a bundle pricing strategy, you could extract each consumer's full reservation price. That is, you can extract all of the potential surplus as profits for the firm. Okay? So that seems pretty good. Now let's look at what would happen if you sold these products individually. So let's start by looking at candy bars. Suppose you set a price that's equal to the vertical distance of this line on the graph. Okay? Then all of these consumers at points who are further up from this line would be willing to buy. Now clearly you're leaving some money on the table because some people have a reservation price that exceeds the price that's being charged. And so you're giving them some consumer surplus. That surplus is not being extracted as profits. And there are some consumers whose valuations for a candy bar fall below this line, and so they're not willing to buy at all. Okay, so there's those two reasons why they're not extracting as much of the potential surplus as they could when they're setting a single price for a candy bar and selling it alone. Now you might also think that they would have a single price for an apple, and the same logic applies there while they're leaving some money on the table. Okay, so just to be very clear, if we were to sort of look at all the points in that blue area, sort of in this upper area of the graph here, all the points there represent consumers who'd be willing to buy only a candy bar. And people in this green shader region here represents people who are just willing to buy an apple, not a candy bar. The point is horizontally further to the right than this line, which represented the price of an apple. Of course, people in this region would be willing to buy both because it's both vertically higher than the price of a candy bar and horizontally further to the right than the price of an apple. Okay, so let's get rid of all this stuff here and go back. Okay, so to go back to what I was saying earlier, when they're charging a price for a candy bar and selling it separately, they're leaving some money on the table because they're not charging each consumer the full reservation price, and some people aren't willing to buy at all. But with bundle pricing, each person's valuations for the two items summed together is exactly equal to the bundle price, at least as I've represented this example. And so that extracts all the profits. Clearly, that's a better strategy in this case. Okay, no, so in practice, it's not true that people's valuations are perfectly negatively correlated. It's not true that if you sum people's valuations that their valuations would sum to the same amount, but it might be something that's kind of close to it. You might imagine kind of there's this like fog of different points here where they kind of follow this straight line, but not exactly. In those types of cases, particularly when marginal cost is low, bundle pricing will be a very effective strategy.